July 1st, 2025. A single telescope in Chile captures something that shouldn't exist. Racing through space at 137,000 miles per hour, faster than any interstellar visitor we've ever recorded, is an object that will challenge everything we thought we knew about the cosmos. By the time you finish watching this video, you'll understand why this discovery has the scientific community in complete chaos, and why one Harvard astrophysicist believes we might be looking at something that didn't form naturally. The object is called 3I/ATLAS, and it's not just another comet. This is the third known visitor from beyond our solar system, but it's moving so fast that it makes the previous two look like they're standing still. When astronomers first spotted it within Jupiter's orbit, they immediately knew something was wrong. Objects don't move this fast unless they're running from something or powered by something we don't understand. But here's where it gets interesting. Within hours of the discovery, observatories around the world started pointing their most powerful instruments at this mysterious visitor. What they found was so unusual that it sparked the most intense scientific debate we've seen since the first interstellar object was discovered. The Hubble Space Telescope revealed a teardrop-shaped cocoon of dust stretching behind it. The James Webb Space Telescope detected chemical signatures that shouldn't exist in a normal comet. And radio telescopes started picking up emissions that made astronomers question whether they were looking at a natural object at all. This isn't just another space rock drifting through our neighborhood. 3I/ATLAS is carrying secrets from a region of our galaxy that we've never explored, possibly dating back 11 billion years to when the universe was barely a quarter of its current age. The chemical composition alone tells a story that doesn't match anything we've seen before. It has 8 times more carbon dioxide ice than water ice, which is practically unheard of. It's loaded with nickel in concentrations that make no sense for a typical comet. And it's displaying behaviors that have forced scientists to create entirely new categories just to describe what they're observing. The most controversial aspect isn't its speed or its composition. It's what happened when 3I/ATLAS got close to the Sun. Every comet we've ever studied follows predictable patterns when it approaches our star. The ice heats up, creates a glowing tail, and follows the laws of physics we've understood for centuries. But 3I/ATLAS decided to rewrite the rulebook. It accelerated faster than gravity alone could account for. It changed color from reddish to deep blue, something comets simply don't do. And it started emitting what some researchers describe as stream-like jets that look suspiciously like rocket thrusters. Harvard's Avi Loeb, the same astrophysicist who stirred up controversy with previous interstellar visitors, has created what he calls the Loeb scale to measure how likely an object is to be technological rather than natural. On a scale of 0 to 10, where 0 means definitely natural and 10 means definitely artificial, he's assigned 3I/ATLAS a score of 4. That might not sound high, but it's enough to suggest that we need to seriously consider possibilities that would have been dismissed as science fiction just a few years ago. The scientific community is split down the middle. Half are convinced that 3I/ATLAS is simply the weirdest natural comet we've ever encountered, formed in conditions so different from our solar system that it appears alien to us. The other half are quietly admitting that some of the observations don't fit any natural explanation they can think of. Both sides agree on one thing, though. This object is forcing us to expand our understanding of what's possible in the universe. Over 30 observatories have now tracked 3I/ATLAS, creating the most comprehensive study of an interstellar visitor in human history. Every telescope that can reach it has been pointed in its direction. Every instrument capable of analyzing its composition has been deployed, and every piece of data collected just makes the mystery deeper. The race is on to understand 3I/ATLAS before it disappears back into the darkness of interstellar space, taking its secrets with it. But as we're about to discover, the closer we look at this cosmic visitor, the more questions it raises about who or what might be out there in the vast emptiness between the stars. October 29th, 2025. 3I/ATLAS reaches its closest point to the Sun, and everything changes. At exactly 11:36 Universal Time, the mysterious visitor passes through perihelion at a distance of 126 million miles from our star. This moment represents what Avi Loeb calls the acid test. If 3I/ATLAS is just an unusual comet, this is where it should behave like one. If it's something else entirely, this is where the mask comes off. The results are immediate and shocking. Instead of following the predictable pattern that every comet in recorded history has followed, 3I/ATLAS does something that makes astronomers around the world stop what they're doing and stare at their data screens. The object accelerates, not gradually, not according to the gentle push of solar radiation that we expect from comets, but suddenly and dramatically, it's moving faster than gravity alone should allow, faster than any natural process can explain. But the acceleration is just the beginning. As 3I/ATLAS swings around the Sun, radio telescopes in South Africa pick up something that shouldn't be there. The Mir-KAT radio telescope array detects the first radio emissions ever recorded from an interstellar visitor. The signals are coming from the object itself, pulsing through space in patterns that make the detection teams double-check their equipment. They've never seen anything like this before. The official explanation comes quickly. Astronomers announce that the radio waves are caused by hydroxyl radicals, OH molecules in the comet's coma. It's a natural phenomenon, they insist, just chemistry happening at speeds and scales we've never observed before. But the timing is suspicious. These emissions start exactly when 3I/ATLAS begins its unexplained acceleration, as if the two events are somehow connected. Then the visual observations become impossible to ignore. Telescopes around the world start capturing images of something that challenges the fundamental physics of how comets work. 3I/ATLAS develops what astronomers call an anti-tail. Normal comet tails always point away from the Sun, pushed by solar wind and radiation pressure. But 3I/ATLAS grows a second tail pointing in the opposite direction, toward the Sun. The physics behind this phenomenon, according to the researchers studying it, remains unclear. By November, the mystery deepens further. New images from Thailand show that the anti-tail isn't disappearing as it should. Instead, it's growing more prominent, defying every model astronomers have created to explain comet behavior. The object now sports multiple tails pointing in different directions, creating a display that looks more like an engineered light show than a natural celestial event. As 3I/ATLAS fades back into the cosmic darkness, carrying its secrets toward the edge of our solar system, we're left with more questions than answers. This isn't just about one mysterious object. It's about confronting the possibility that our universe is far stranger and more populated than we ever imagined. Whether 3I/ATLAS turns out to be the most unusual natural comet ever discovered, or something that challenges our understanding of what's possible, one thing is certain: we are not alone in asking these questions, and the next interstellar visitor might provide the answers we're searching for.